welcome to my channel. And I'm just going to put this disclaimer at the start of all my videos that I'm re-uploading. 5 years ago I solved the double slit experiment with a simple inequality, and all the physicists I approached about it refused to listen because it goes against what they have become embedded in believing. And I solved a grand unified field theory from it, which solves and fixes everything in physics with clear, simple mathematics. The equations of 137 being vortex equations. They're not particles, they are vortexes moving inside a space-time fabric. I give the quantum field structure, I give 26 dimensions held together by strings, which are actually elastic pipes. Explain quantum gravity, dark matter, dark energy, everything in physics. But because it proves the particle model wrong, and because it proves the Big Bang wrong, the people in power refuse to listen. But they don't just refuse to listen, they've consistently destroyed my work and had it taken offline. So in my videos I'm quite angry, so please excuse that. If you can, see it as me being the guy in the Titanic, getting the message, there's loads of icebergs coming up ahead, and me saying to the people in control, okay, steer a different course, this is the correct way, and those guys going, don't listen to him, hasn't a clue, this is the Titanic. We've got it all sorted. Thanks, enjoy the video. The demonstrations in this video are based on an inequality found in peer-reviewed experiments, which prove that the interpretation of data, known as the standard model of particle physics, is incorrect. I'm going to try again to explain what's happening in the double slit experiment. And what I've said to all the physicists for the last year and a half, and they've all told me it's irrelevant, it's not important, it's vital, what's happening on the front screen. If time were one-dimensional and the standard model of particle physics, where a particle is travelling through space, if that was correct, then it shouldn't matter what happens behind, whether it's being detected for which way or not. The marks left on the front screen should be roughly the same. Most of the marks would actually hit the front screen, and some would get through the slits. So I'll try it first. I've got this little soggy paper. I'm going to throw it at the front screen and see. Some will get through the slits and some will should get stuck. It mightn't get stuck, but hopefully they will. And here we go. Alright, one hit the front screen. Yeah, another. See, one went through the slit there. Not many. Most of them are going to hit the front screen. So I'm gonna cut the film here and do a few more. See what happens. Okay, that's a particle. That's a mark from a particle, and we should get that regardless of whatever way the experiment is being run, whether it's for detection or not. Okay. So quite a few shots later, what do we have? We have quite a lot of hits on the front screen. And so that's particle. So the particle should have gone through, and we should get the twin band on the back wall. That's what we expect, isn't it? So let's see. We'll take out this photosensitive material, and what do we have? We have an interference pattern. Marks in the front wall, and we have an interference pattern. Because time and matter have an inverse relationship in this experiment. And we think, so what I'm going to do next is I'm going to run it for which way. But the inequality that I found, if you look at this one here, when you don't do detecting for which way, if you look at the video from Nebraska Lincoln University, their physics department in 2013, and you look at the recording, they recorded the back screen and how many hits made it through to the back screen, and you see that it is consistent with what we are expecting on the front screen here. Most of the hits seem to not make it through to the back screen, and a few do, which is consistent with what we hear. But they get the interference pattern. Not what we expect.
And the inequality is that both can't be right. When we do it for which way, we find that every particle makes it through. I'm going to do it in a minute. But and initially I thought we have to look at the front screen and find out what's going on. But actually we don't. Because either way, the evidence from Nebraska Lincoln and from the which way experiment that's explained in the video on YouTube by the lecturer by the Royal Institute. In that video, they say that the particle, they call it, either goes through the left or the right slit. 50% of the time it's detected going through the slit with detection, and the assumption is that the other 50% of the time it must be going through the other slit. So that's 100% of the time the particle is going through the slits, which is not consistent with this. We should expect some of them should be hitting the front screen like this, but that's not what's happening. And I'm going to run the which way detection for which way next to see what happens. So from the evidence we have already, we know that the standard model particle physics isn't correct, and I'm going to explain after the which way the correct model briefly. So now I'm going to try the experiment for which way. Imagine we're detecting for which way behind that screen. Now, as I said before, what should be happening on the front screen should be the same, regardless of what's happening on the back screen. If we're throwing firing particles, some of them should be hitting, leaving a mark on the front screen. Okay? That's not what happens. Okay? So, here we go. Firing a particle, front screen. Went through, didn't hit front screen. Through again, didn't hit front screen. Again, didn't hit front screen. Through again, hitting it. I'm gonna cut the film here. I'm sure you don't want to watch me doing this. I'll throw a few more, and you'll see that they all go through. None of them hit the front screen, which is impossible if time were one-dimensional and the standard model of particle physics was correct. Okay. So the only way that this can happen is if it was waves going through. So when we do it for which way, it must be waves that's passing in through the slits. But what happens then? Let's see what kind of a mark we get after firing all those particles in through the slits. Let's see. Take out this photosensitive material. And what do we get? We get the twin band mark. The opposite of what we should expect from a wave. Okay? Ding dong. Because matter and time have an inverse relationship in the experiment. When a particle acts, when energy acts like a particle in time, it leaves a mark in matter like a wave. When it acts like a wave in time, with the which way, it leaves a mark in matter like a particle would. And I'm going to explain why. Because they're not particles. It is energy moving through the field. Now, we've traditionally thought that space is empty. It's a vacuum. It's not. It is dark matter. Everything and everywhere that we are, it's a lattice. It's an absolutely clear lattice that the only way we can detect it is with light coming through. And there's only two forms of energy. There's light moving freely through the lattice of space-time. Dark matter, it's the same thing. And there's where light has got caught in vortices, and these vortices twist the fabric of space-time. And that gives us matter. Matter. We are collections of light spinning in vortices within space-time fabric. So it's energy that's being fired and hitting another vortex somewhere. That's what is in the experiment. And what is happening, the effect, the difference in the experiment is to do with focus. It's conscious focus between two operators. Those who set up the experiment and the field itself. The space-time lattice, fabric, dark matter, is a living tissue that we move within. It is traditionally what we call God. Just the same as we communicate with all the cells in our body, the universe communicates with us. We are the cells within the universe. And when we set up the parameters of the experiment, when we set the timing, the universe responds. What the conscious operators are affecting in the experiment is the measurement. They are narrowing the measurement from a wide range of time to a narrow range of time. Time moves forward, but in every moment it oscillates in 13 dimensions. So we have 13 to the power of 13 possible moments happen within every tick, every quantum tick, every moment in time. And it's we can only measure in one dimension of space and one dimension of time at a time. Even if we calculate the volume of a cube, we measure one side first, one space, one time, then the next one space, one time. It's always one step after the other. That's all we ever do. We always measure in one dimension of space and one dimension of time. But when we're not detecting for which way, we have a wider area, a wider space, and a wider time to detect. It's always one dimension that's being detected, but there's 13 to the power of 13 possible directions within that oscillation.